read that one. As in like math, not future events, as in like stock market. Don't get too excited. Uh, okay, this unit, knowing how to use sine law and cosine law is not the most difficult part. What do you think the most difficult part will be? Drawing, sketching the scenario, getting it right, putting the numbers where they belong, right? Knowing how to proceed. And I'm here to tell you that there are lots of ways of solving these. My way is just one way. You are probably going to be able to do it in your own way. As long as we have the same answer, I really do not care. I do not care. You just have to be very careful what you're assuming, okay? Some assumptions are deadly, right? So then you assume something is here, it's the height, and then but you get it wrong, right? It's not really. So you got to watch out. So apparently I assigned this. I got the page numbers mixed up. It doesn't hurt. So an airplane observes, and there we know that we're up top, and there'll be an angle depression. We should know right away. Oh, okay, I know what this means. I know where this is going. Okay, points and to points A and B. Okay, the opposite on opposite shores of the lake. So points A and B are like either end of the lake, and they measure 32 and 45. Watch this in math. Well, any word problem. If it says point A and B and then gives you angles, it's most likely gonna be respectively. So the first belongs to point A, the second angle belongs to point B. That's usually how it goes. Although I suspect it wouldn't really hurt you here. Okay. Then it says a plane is flying at an altitude of 9750 meters. So we know that this is the height. We also know that the height makes a 90 with the ground. Okay, you got to be very careful there. And it's not directly over the lake. So it's not like the helicopter with the crash scene and the ambulance. You're right in between somewhere. This is not. You're not on over the lake. Okay. So determine the width of the lake. That's our ultimate goal. So here we sketch. Okay. This is the plane. I'm very, I guess the side of my brain, I always go from left to right when I draw stuff, but you could go the other way. It doesn't matter. So we have the plane or the pilot. We're looking at, this is our lake here. Lay it out, right? Point A and point B. And so you're looking at point A, that's one end of the lake, and you're also looking at the other end of the lake. Yes, some of you went put waves here, right? This is the lake. And of course, it's going to be like round or whatever, but we have like a certain amount of like a width that we'd like to calculate here. So how do I put in my angles? Well, this has to be a horizontal line here somewhere. And which one should get the 32? Well, I would say the smaller one that gets you to point A. And then maybe what I will do here is I'll use colors. So 32, right, just that angle right there is 32 degrees. And I need a different color. I'm going to try green. And if you'd like to see it this way, this whole thing here is 45. Okay, that whole angle is 45. So you got to watch out where you put them. Both of them have to be measured from the horizontal down. You can't put the 45 to 32 somewhere in there. It's not correct. Okay, now I'm giving the altitude. Well, that's for the plane itself. So that should go straight down to the ground. And I'm just going to sneak in. Basically, you're sneaking in a right triangle, okay, into the mix. So that's 9750 meters there. There's your altitude. So this is what the scenario is calling for. Now I have lots of numbers that I can move and shuffle and do whatever I want there, okay? For example, to get this angle right here, I'm going to use a different color to just get this little wedge. This wedge corresponds to this obtuse angle, triangle right here. How would I do that? I would go 45 minus 32 gives me that. So I'm going to do that work here. 45 minus 32 is equal to 13. It's Friday, so you got to watch out with my math here. Right? 13 degrees for that wedge, right? So you did a little bit of calculating to come up with that. What else can you calculate? The diagram is probably a bit too small for you to see, so here we go. So here you have to be very careful, okay? This 32, I'm going to ride this line right here. I know that this 32 is, I can use the alternate interior property and put the 32 here. Alternate interior angles. That's what I use there. You don't have to tell me this on an AC. I don't really need this, but I'm just letting you know. What about this line, this transversal here? Oh, the 13, Mr. Dirksen. Look, 13 is touching it, and then no. Remember, it's with a horizontal, right? So there's a 45 touching this side, so I can bring the 45 in here if I wanted to. Right? So it's the whole thing and the whole thing here. What else can I do? Sum of triangle, yep. Yep. So gotta watch out. There's this angle, this angle, this angle. So I can figure out this one. Can I also use supplementary angles here? Yeah. So you know what I mean? There's many ways to get there. So what is that? Jillian, did you do the math already? You were doing? Yeah. Okay. Did you subtract this from 180? Like the 32 and the 13? Or we can just go 180 minus 45, right? It's 135? 135? You're going to confirm? Yeah, thank you. Bingo. Is it possible that I did too much? TMI, right? I always tell my kids too much information, sometimes too much detail, right? Like, but it doesn't hurt. So now we can start narrowing down, like, can I solve for the lake? What do you think? I would argue not right away. I can't do it just off the bat, right? Because if you think about it, if you work with this triangle right here, all you have is 3 angles. You don't have a single side. So what do you have to do? You have to go and use the height. Work with this triangle. Work your way closer to this triangle. So my strategy is usually I'm going to find the one that they share, the right triangle and this one. That's my strategy. So I'm going to call this Y, this side right here. And I'm going to call the width of the lake X. So then I have my, usually X is like the ultimate, and then Y is something in between. Okay, so work with right triangle and solve for shared side. Okay, that would not have been in the key probably if you did this, that detail there. Work with right triangle and then shared side. So I like to have a little bit, because remember, these are your notes. Come exam time, right? If you have detailed notes, it's going to help you greatly. I know that this is 45 down here. I can copy it from the top here. And so what law am I going to use? Sine law. I've got 45 and that. Quick fact about this triangle. What kind of triangle is this? A right triangle, but it's more specific. If this is 90 and this is 45, what's this one? It's actually also 45. If two angles are the same, and this is called an isosceles, right? What? Right, isosceles. So that's just an added bonus there, which means that technically, folks, this is 9750. We know that without doing math because if these two angles are the same, so are the sides across from them. Okay? That's just an added bonus. You may have never noticed that you could have done a bunch of math and be like, wait a minute, why do I get the same answer? Because it's an isosceles triangle. Okay? I know, I blew your mind right there. However, I'm interested in y. So I'm going to go sine of 45 over 9750 is equal to sine of 90 over y. See, I do know, I know SOHCAHTOA would have been a lot faster here, but that's okay. So we're going to multiply these two. Sine of 90 is just 1, so it's irrelevant to actually plug that in. Doesn't matter. So I'm basically just going to go 9750 divided by sine of 45. That's 13,788.58. And you know what? Technically, because we're not done yet, I'm going to use 4 decimals. And we are in meters. Okay, we now found y. It's important, so I'm going to underline it, but it's not the ultimate yet. I'm going to go 1, right? This is where I started. Then I'm going to cut this here because I like to organize my work. And I'm going to work with, I'm now going to zoom into this one here, and I'm going to replicate that to the best of my abilities, okay? This is x, that's the width of the lake. I now know that this is 13,788.58 something. I know that this is 135. I know that this is 32. And I also know that this is 13 up top. I know a lot of information about this triangle. I have a pair again, correct? It's very hard to see, but the 32 is across this side. So I'm going to use sine law again. Sine of 32 over 13,788.5822 over, what do I have to use here? Sine of 13. Yeah. Sine of 13 gives me x. So then you cross multiply. If you ever get a teacher that doesn't like this, like they want to do it the old school way, and they ask you who taught you this, you don't know, okay? It's like, I don't know, YouTube. Right? Cross multiply and divide. Sine of 13 divided by sine of 32. That's 5,853.26 meters. Does that match my key? Is it you? Yeah, it match my key. Yes. Off script is great to be in the moment, but sometimes it bites you if you get it wrong. What does it ask? Determine the direct distance from the plane to point A. It's asking for PA, right? It's asking for the direct distance here. Let's call that Z on here. You should call it, right? If you want to be smart, it's like, call it O, 0. Right? Anyways, determine the direct distance. So we're just gonna use the same pair that I already used before. 5822. But now I'm going to use what? Sine of 135, correct? Over Z. So it's just as simple as that. And again, using sine law, cosine law is not the problem necessarily. Usually it's not. It's coming up and interpreting the question. That is the key here. Z is, if you cross multiply and divide, divided by sine of 32, 18,399.03 meters, which is to be expected because 135 is the largest angle. You expect the longest side to be across from it. All right. And now it's going to be AC time. Okay. I hope this helped you. But remember, I'm going to take you back. If you ever want a review again on possible scenarios, 35 is where it's at. Okay. You cannot use it for your test. Students have asked, can I like rip this out and bring it? No, you can't. But this is just to help you, right? When you're right over top of something and you've got two angles of depressions, right? You're looking to either side. Watch for the wording. This is the one we just did here. This is the airplane, right? A pilot looking to the same side. There's an hot air balloon, right? You're looking at the forks and another building. You're looking out to the same direction. And so you've got that kind of going on there. Page 35, okay? And then angle of elevation, because I can't cover every case, but these are the easier ones in my opinion. You've got wires, this one would be the wires supporting a tower. This would be two people maybe looking up at the same object that's right in between them. So that's what I would categorize that under. And then these ones are probably the trickier ones. I'm just gonna give you a scenario, right? Like you're over here, you're looking up at a building, you move in closer, you look back to the top, right? So that would be the scenario here. Always remember, supplementary angles are your friend. Sum of triangle is equal to 180 is also your friend, right? There's gonna be a right angle there. If it's a building that you're looking towards or a cliff or anything, we're assuming that it has a height to it. And then this one is the less common. This is when, let me think of a scenario here. Maybe let's look at it this way. You're standing still, right? You're staying in your spot and you're looking up to a bird flying, right? But over top of that bird, there's a plane, right? So you actually have to you have to tilt higher. You have to tilt your head higher to look at the plane that's above it, immediately above it, right? So you could figure out what the distance is between the bird and the plane, essentially. If you turn this, let's do that. This is essentially almost like it's close to the one we just did with the lake. However, you don't have angles of depression, do you? You don't. Because in this case, the horizontal reference is the ground. You're measuring from here looking up, which is an angle of elevation. Okay, so you have to be careful there. Okay. All right. Let's pause here for now. So the question was, could we have used this whole triangle here? Right, this big right triangle, you see it? I keep going over it so you don't miss it. Okay. Could we have used sine of 32 over 9750, right? This is my pair. And then found, and then use the angle up top here to figure out the entire length, the bottom from here all the way to here. And then later find this stretch and subtract it, right? You have your hole and you subtract that stretch from it. Absolutely. If you're careful, you're going to get the same answer. Let me do this on scrap paper. Okay. So the question was, I'm going to focus just on that right triangle. This one, the big one here, and then there's another one right here. Okay. This is 9750. This is 32. So if you're working, just pay close attention because I might lose you here. If you're working with that one, and then you would call this whole thing, I don't know, M, let's say. You just have to be careful. If you use sine of 32, 9750 is equal to, what would be your pair? Because you want to know M. You need to think of M goes from here to here, so you need to have this entire angle here. Okay, how would you find it? Well, if this is 90 and this is 32, you can easily find this, right? You just subtract this from 90. Okay, what are we at? 60, 58? This is 58. So you would use sine of 58 over M, solve for M, and then later zoom in to N, right? Then work with this little triangle. And I think, what was this again, 45? Yeah, this was 45. So we could have found this stretch, which we know is 9750. So once you find M, subtract this from it to get X here. Absolutely, it works. If you're careful, there's many ways to solve this. Okay, that's actually the cool thing. In my opinion, you might disagree. You're like, no, I want to do it the one way, which is easy to follow, right? But unfortunately, it's not the case. All right, good question. So again, write this down on page 46. All word problems. Some focus on different things, so still give it a go. I already posted the keys. To the video because I'm seeing this here. The AC that I gave you, I'm going to have this on the video, so if you miss what I'm saying right now, just go back to the end of the video. But question 2 has a speed, 20 miles per hour, 25 miles per hour. If you know the time you've traveled at a certain speed, right, you can figure out how far you've gone, can't you? If you're going 100 kilometers an hour for 3 hours, you've gone 300 kilometers, right? So that's the added, little nugget here on this one for question 2 on the AC you're taking home.